And now it's working perfect. Was something bugged. Where is it? Okay. So browser, boom. Okay, let's keep going with unary.
I'm just going to declare a variable a of size 7. I'm just storing the number 7 to that variable a of type int, and following that I'm just going to perform a plus plus. So after executing same manner and minus minus, we are just going to use these two operators in the same. So let us see with an example how this unary operator functions. So here in the program, I'm just going to declare a variable a of size 7. I'm just storing the number 7 to that variable a of type int.
10 minutes. Oh no. It seems this is a rabbit hole, right? There's not a good explanation, right? Binary operator definition. What is unary? I just need a definition. That's the operands, like, okay, and then we have the operator. Maybe this is a good example. Okay. First definition is in mathematics. A unary operation is we calling an operation is an operation with only one operand. So this is okay. For example, single input. We have only one input. Okay, I got it. This is in contrast to binary operations. Here we go. Here we're gonna see it. Perfect. Okay, got it. Which use two operands. An example for okay. Common notation preview. Okay. Yeah, okay, got it. This is used to find the negative value of a single number. This is some example. Unary okay. Unary negative and positive. 3 minus 2. As a unary operation have only one operand. True. They are evaluated before the operation containing them. Here's an example. Here, the first minus represents the binary subtraction, and the second one is the unary then, while the second minus represents the unary negation of 2. This is really interesting, though. So, got it. So if you're overloading a unary operator, gotta do so as a member function. If you're overloading a binary operator that does not modify its left operand, operator plus, do so as normal function preferred or friend function. What is a normal? I mean, you can do, yeah, okay, got it. If you're overloading a binary operator that modifies its left operand, but you can't add members to the class. Definition of the left operand, for example, operator insertion, which has left operand of the type ostream, do so as a normal function, preferred, or friend function. What is now? What is a normal function? What do you mean with normal? Do you know? Difference between inline and the normal function in C++. Okay, this is inline. I already forgot like the full topic about inline. Dude, this is crazy. Inline function to multiple blah blah blah. Main driver method function. Execution blah blah blah. Okay. Name success. Normal function is basically simple. A simple common function in C++. Okay. Okay, got it. Simple is good. We're not gonna dig deep here. Preferred or friend function. If you're overloading a binary operator that modifies its left operand, if you modify the left, then you're gonna use the friend function. For example, operator plus equal, and you can modify the definition of the left operand to so. Oh no, member function. Left was member, correct. If you have to modify it. Holy moly. Next topic. Overloading unary operators plus, minus, and it's keep going, right? It is keep going. Terrible. So overloading a unary operator plus, minus, and how is this called in English? Hey, Trade Passer, how you doing, man? How this is called in English, by the way. Unlike the operators you have seen so far, the positive plus, negative, minus, and the logical not. Okay, I will just call it logical not. Operators are all are unary operators. Gonna take computer for a degree. Any tips for C++? Yeah. What do you mean for degree? Like you want to study it or what? So what are you gonna study? Like software engineering or engineering or? You don't know yet. You don't know. Okay. I mean, if you, for example, doing engineering, it will not be. It could be. It will that it is not going to be C++. It can be C. It can be Java. I don't know. Maybe even Python. I don't know. The truth is about if you really want to learn programming, it will take some time, right? And C++ is really special. And in university, if you, for example, in doing engineering, you're doing also a lot of overjumping, right? And C++ is so huge. So maybe it's good to start with C into C++, but then you will end up that you're using, for example, C in C++, right? Because you can. So then you have to relearn stuff, right? But maybe it's the cleaner curve. Right, because if you're starting with C++, it's like super overwhelming. You know what I mean? For example, if you know the website learnc++.com, it's a really good website so far. You know, if you just learn it by your own, you can go to this website and learn all this. See you in 1 year. Probably you will, if you learn every day, maybe it will be 3-4 months. But if you really want to understand what's going on, you have to check also a little bit assembler, right? It's called assembler, not assembly, assembler. And logic gates, you have to understand how logic gates are working and stuff like this. It's a long journey, right? And if you're in university and you're learning, for example, have it for exam, in exams, you're over jumping also a lot of topics, right? So it's kind of special, but it is cool. I would do it. Like, maybe I would start with C. Because C++ is really overwhelming. And you're ending up to go to C, and some stuff is in C a little bit different compared to C++. But you have to have a basic understanding about C to understand sometimes C++. For example, memory management. Yeah. But this is really good. So you can just start. You know what is really good? You can say, okay, I do every day one topic, for example. And you have to relearn even the topics, right? And yeah. But if you're gonna study, learn every day, don't try it. If you're in tech, if you try to learn like everything, like in school, like 2 weeks before, it's not gonna work. Maybe if you're like a super brain or something, I don't know. Maybe then it's gonna, but it will be way less stressful for you if you're gonna learn every day a little bit. It's even way more chilled, right? Way more chilled. But it's really good. Learn C++ is really good. I think there's also like a website for C or something. And watch out. There are a lot of YouTube videos. They actually are not that great. There are also a lot of C++ content out there in the internet. That's not that great. Then it's maybe better to go to Amazon or like just, getting a good book. That's it. Getting a good book. Learn every day. A good book with a good rating. Because you don't want to learn something that's actually not correct, right? That would be like just really, really damn bad. Okay, let's go to the topic. Oh, yeah. Let's keep going. This is here, right? Oh yeah, not. Operators are all unary operators. So I can say, do you know what is a unary operator? A unary operator is like if you have the operands, right? You have only one operand. Is it the operands, right? Yeah, you have here the operands, right? And you have only one operand. And it's like, it's gonna, you have only one input. Right, one input. I said you have to know how logic gates is working. Here was the example, right? Let's give me the example. Here, you have, for example, x is equal 1. Then you have epsilon is equal to, right? And unary, you have only one input. That's why math is also really important to understand stuff, right? Which means they only operate on one operand. Yeah, okay. Could just read the sentence to the end and then I would have it already. Because they only operate on the object they are applied to. Typically, operator overloads are implemented as member function. Okay, makes sense because we want to modify the left side, right? That's... Wait, was it the left? Oh, dude. Right, I have to check. Um, for this we need a friend function. Yeah. Because we can't modify this, right? Mm-hmm. Yeah. Mm-hmm. Yeah. I'm already a little bit confused, to be honest. I'm just gonna dig deep here. All three operators are implemented in a identical manner. Let's take a look at how we do implement operator minus on the sense class we used in the previous example. Okay, let's see. Okay. Class sense private in blah, blah, blah. This is our member public. And then we have our constructor here. We define mSense as sense, right? Here we initialize it with 0. And then here we're going to give it like the sense. Then we have overload sense as member function, sense operator minus const, right? Const is read only in this case. And this is our assignment operator, if I'm correct. Then we have integer get sent. This is our function. Then we have const is again read only, and then we return mSense. Okay. Overload sense as a member function. Yeah, that's a member function. Then we say, okay, this function is a member function. Okay, we know this isn't a member function, and it's also read only again. Return minus mSense. So we're just gonna this is like here we have the, if I'm correct, please correct me if I'm wrong. This is a forward declaration. Here we declarating it. Is it deklarieren? I don't know. Let's see. Declare. Okay, we're gonna declare it here. Okay. Then we have the main. Then we say, okay, const sense nickel 5. And yeah. Okay, because we have the minus here. Okay, got it. This should be straightforward. Our overload negative operator minus is unary operator. Implemented as a member function. So it takes no parameters. It operates on this object. It returns a send object that is the negation of the original send value, because operator minus does not modify the send objects. The send object. Okay. Because operator minus does not modify the sense object. But if I have the friend function, I gonna modify it, right? Really? Or is it the other way? I'm already confused. We can add should, make it a const function, so it can be called on constant objects. This is so confusing. Note that there is no confusing. Note that there is no confusing between the negative operator minus and the minus operator minus, since they have a different number of parameters. Here's another example. The logic, it was not right. Operator is the logic negation operator minus if an expression evaluates to true. Operator, the not operator will return false, and vice versa. You commonly see this apply to Boolean variables to test whether they are true or not. So, yeah, okay, makes sense. Mhm. Got this. For integers, 0 evaluates to false and anything else to true. So operator, the not operator is applied to integer will return true. Okay. For an integer value of 0 and false otherwise. Extending the concept, we can say the not operator should evaluate to true if the state of the object is false, 0 or whatever the default initialization state is. The following examples show an overload of both operator minus and not operator for a usual defined point class. Okay, wow. We initialize this. This is clear. Then we have public. Then we have our constructor here. Okay, this is also clear. Convert a point into the negative equivalent. How is that called?
Equivalent.
Okay. Then we have point operated. Blah 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 blah. Const. Okay, it is const. Because we're not going to change it. Okay. That's forward declaration here again. Return true if the point is set at the origin. Bool operator. Okay. Const. Okay. Got it. So here we have our functions. Then convert a point into the negative equivalent. Okay, we're using the member function and then we just return minus blah blah blah. Okay, got this. Okay. So you can check this quick. So we have the friend here. This was it. Not the friend function thing. Okay. It's const. We're not gonna modify this. Okay, got it. Okay. Okay, this is here we're gonna modify it, blah blah blah. Even if you're saying operator minus is const. What is this const doing then? Can someone explain? Read only. Yeah, the function is const, so the function is only read only. So why we want that this function is only read only? Lunatic, how you doing, man? Why I'm confused right now? I have to read it again. Wait, here we had like the explanation. Yeah, I tried it out already. I should put it out of the title because I'm gonna learn it in after my exams. I started to learn it and then I had like a break for 2-3 weeks. It will take some time, so I'm gonna try NeoVim, but I want to change my layout a little bit also for programming, because it's also like the German layout is not the perfect layout for programming in my experience right so far, so it's better to use the English one, and even you change the caps lock because you can use it for something else. Oh, okay, this is why it's a const. So you're using NeoVim, by the way. Yeah, it is. I think it's cool, but you need some practice for the muscle memory. I think it's good. I just started using it like 2 weeks ago. The truth is also, yeah, it's really good. You have also like there, you can have a debugger. The thing is, if you're using, for example, Visual Studio, the debugger is really good, right? Some people don't like debugging, but it helps me also a lot to understand in my learning journey how stuff is actually working, right? Because sometimes I'm expecting it's going to work like this, and then I'm just going to use the debugger and then figure it out. It's going to work completely differently. So let's read this again. This is straightforward. The overload negative operator minus is unary operator. So it's implemented as member function. So it takes no parameters. It operates on this object. Okay. Because I'm using the member function. Okay. It returns the send object. That is the negation of the original send value. Because operator does not modify the send. Ah, okay. We're not modifying the class, right? Wait, does not modify the sense object. Boah, this topic, man. This overloading thing is crazy in C++. But no, there is a really good debugger. There is a really good debugger in NeoVim. I think I even have the YouTube video. I'm gonna check it. Give me a second. Not this one. I have to go here. Let me check. By the way, this is my brother. So, no. I'm gonna find it for you. I'm pretty sure that I have something for NeoVim. What? Am I lazy? I mean, I have even Rust. Right, maybe it's here. Okay. Was it this?
In this video, we're
Yeah, it was this.
If you have any other languages or tooling that you'd like me to do in this series, then let
Gonna link it for you. Give me a second. You can just use the... debugger. Here. So, okay, back to const. It returns the send object. It's good. The thing is, sometimes I think you should not use newvim to that it's gonna look like Visual Studio or something. I think it's not a good approach. Just my opinion, right? But the debugger could be interesting, right? What do you want to link here? I mean, you can link here if it's legit, you know. Like, what do you want to link? Ah, okay. Haha. Haha. Of course, something like this you can link. Wait, go on tweet. All right, what? Oh, fuck, I don't have the chat open, right? Oh, I'm really. Oh man. I mean, yeah, let's go here. I should get a link. Oh, classic. Classic. Oh yeah, by the way, this is a really good website. Scroll down to the member function and it's with okay. Say stop. Ah, here we have it. Gonna save it. What is a CV qualifiers? Let's see. A member function with CV qualifiers. An implicit or okay object member function can be declared with the CV qualifier sequence const. Ah, that's the const thing, right? Okay. Volatile or combined of const or volatile. This sequence appears after the parameter list in the function declaration. Function with different CV qualifier sequences or no sequence have different types and so may overload each other. Oh, fuck. Sorry, said nothing. In the body or a function with a CV qualifier sequence, this is a CV qualified. For example, member function with const qualifier, only other member function with const qualifier may be called normally. Maybe called normally. Oh man, this is getting, man, C++ is so cool, huh? A member function without const qualifier may still be called if const cast is applied or through an access path that does not involve this. Oh, this is so brutal. This is so classic C++ style. This sentence. I'm gonna read it again because it's so juicy. In the body of a function with a CV qualifier sequence, this is a CV qualified, for example, in the member function with const qualifier. Only other member function with const qualifier may be called normally. Maybe. A member function without a const qualifier may still be called if const cast is applied or through an access path that does not involve this. This is so brutal. Okay, let's see. Okay, we have a struct array. We love C++. C++ best language. Yeah. I mean, to be honest, guys, if you're learning C++, I think that like this, it is like a special kind of human beings, right? Can we say that? Pretty sure about this. You have to love this to learn it. Otherwise, you would give up. So we have std vector integer data. Okay, array int. Okay, got this. Okay. Const member function. Then we have int operator. Okay. Okay, this pointer has type const array. Return data. Okay. So it transforms to this data. Okay. Non-const member function. This pointer has a type array. Here we have the type const array. Here we have, okay. Transform to this, there is the same, but this is only read only. Okay, the type of 1. Here we can, okay, and then we say const array 10. That's not gonna work, right? So this is not working because this is const, right? It's gonna use this here instead because we set it on const, correct? So we have here this overloading array. The thing is, I think I get it because I did already some overloading things. And it's like, if you're not doing it this way, it could choose rather this or that. Correct? So we would like have undefined behavior. Behavior. Wait. There was behavior. Behavior. Is this a reason? A always choose the non-const. Okay. AC always choose the const version. Correct. But if I, for example, if I'm not defined it, right? Come on. So, okay. Let's try it out. We're going to remove this here. And then we say, okay. Still we're getting an error. Read the error log, Sven. So no variable overload operator for the type const array. The type is called is okay. Okay. I'm still not understanding it completely. So I'm not understanding this sentence. In the body of a function with the V qualifier sequence, this is CV qualified, for example, a member function with const qualifier. Only other member function with const qualifier may be called normally. In a member function with const qualifier, only a member function with const qualifier may be called normally. May be called normally. A member function without a const qualifier may still be called if const cast is applied or through an access path that does not involve this. Boys and girls, I think you have to carry me a little bit here. So why is this overload not working? This expression is not assignable. Okay, this is not unary, right? So first, this is not unary. It's trying, CI is trying to modify the value stored at CA1. Okay. This pointer is const, right? That's why I can't modify it. Notice that the non-const version returns an int L value assignable. right hand value, left hand value. So my question is, if I'm getting here an arrow, why I should even do this here then? Okay. Because if you remove that, you can't do array const. You mean CA, right? CA2. I'm a little bit confused at the moment. You mean I'm not able to do... So we have this, and you said I'm not able to do what? Let's see. Do array const. Okay, this is working. I can say CA is 2. What is this returning even? Okay. Probably it's not assigned, right? I can't do this. So we're getting 0. And if I not have this one here, ah, This point runs type const array. So here I'm creating this object, right? With the size, what is the size 11, right? Is it 11 or 10? I don't know. Sometimes I'm confused. Then I can read it out. So I can create it. No, here we're creating response. So we have this size. And we can read out, right? But we can't modify it. If we have not this definition with const, you're gonna run into an error. Because it's not defined, right? And here we have the reference to this operator. Oh, this is juicy. Wait, I'm gonna read chat. I need chat open somewhere. Let's see. And now, okay. Wait, I have to open it up here on screen. Give me a second. So, okay, the constructor calls the std vector constructor with which file the vector with 0. Now remove the non-const version. The assignment write is now illegal. Okay, what should I do? Wait, let's see. Now remove the non-const version. You mean I should remove this here or what? You mean that? Yeah, it makes sense. Right? Then first we have no overloading thing here. And wait a second. It is gonna choose this operator for the overloading? Really? Don't tell me. It is, right? Oh my goodness. For real? Oh. Oh, okay, but it makes sense, right? It does. So now the sentence makes sense. In the body of the function with the CV qualifier sequence, this is a CV qualified. For example, in the member function with const qualifier, only other member function with const qualifier may be called. But why they have like may be called normally? A member function without a const qualifier may still be called if const cast is applied or through an access path that does not involve this. Okay. Okay, I get it. But why we have here still only other member function with const qualifier? Maybe called normally. Why we have here also maybe? The const of yeah, no, just say I promise to not change the object. That makes sense. That's a really good explanation. But but maybe you don't care, so you can still call it on a non-const object. Yeah. Is really equal can be? Really, maybe it's like the same? Ah, okay. Wow. Okay, language barrier here. Ah, we have maybe. May. Of course, I'm learning also English. Maybe. In Germany, yeah, in German. But But here we have also. Ach, kann sein. It's also, huh? Perhaps, maybe, can be. Now I'm so confused. Next level shit here in with English. So möglicherweise, eventuell. I don't know the difference. Last one should be perhaps. Okay. So if it's maybe, it's like can be. That's weird. So if you have like only other member function with const qualifier, maybe. But then how should I translate this then? I'm gonna just translate it. Let's see. English, Deutsch. Oh, classic. Ja, super. Oh, okay. Okay. Okay, then it was like a language barrier thing. Kann sein. Okay. That's weird. So okay, last one should be okay. Member of a const can only call other member functions. I promise not to eat your food. So I also promise to not give it to Hungry Harry. But this with maybe is weird. Because it's completely translated like differently, right? It's like not even in there. Werden. Können. Ah. Wow. Okay, I learned today a little bit English also. Interesting. This is interesting. Okay. Okay, a little bit English barrier involved also. So English teachers often respond to can I go to the toilet with don't you mean may I go to the toilet? Yeah. Interesting. I just fall for that. Okay, we have this topic now, right? We have already next topic, right? Ah, no, it was this this here, exactly. In the body of the function with a CV qualifier sequence, this is a CV qualified, for example, member function with a const qualifier. Only other member function with const qualifier may be called normally. Okay, a member function without const qualifier may still be called if const called is okay. So that means we have this example here. You still can call it, right? The other way around, it's not going to work. If you have it like this, and we not have this here, and have then our const here, and even if you're deleting that one, right? Gonna have the arrow. Yep. The other way around, it's gonna work. Wow. Crazy. So an access path of doesn't okay. Const qualifier may still be called if const cast. So transform to this data index, this data, okay. Here we're gonna say we're not gonna change the object, right? Here we can the this pointer has type array, and this pointer has type const array. That means I can't change it. Okay, got it. Really interesting. So so then we can check this here, right? This is the topic. So for integer 0, evaluates to false. Okay, we have this extending the concept. We can say the operator should evaluate to true if the state of the object is false, 0, or whatever the default initialization state is. The following examples show an overload of both operators minus an operator not for user-defined point class. That makes sense. We have this. Yeah. Still have a problem with this here. Why we have to do it like here? Also const with minus. Because the minus can be unary, or if you have double minus, it's like kind of special. Is this the reason? Point, so it's 0. Use default constructor set to 0, 0, 0, and then we have this point is set at origin. Point is not set at the origin. Oi, 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 oi. Yeah, I can do this. True. So I'm creating it 0, 0, 0, and then we're gonna call it. If this is untrue, the unit operator does not take an argument. The binary one does. Right, I'm gonna check the binary one. What is the binary one? This here or what? This is also unary, right? Yeah, but then you can do it like without const, correct? In this code example. Gonna check it. Then it would be not a good example, man. Oh, you're getting an arrow. Ah, we have it here. That's the reason. Okay. working, right? Yeah, but okay, I got it. But it's like they could have like a better example, like a binary one and one without binary, and then just with the sentence. What you just wrote, sure, but since it doesn't change the object, marking it const is the reasonable thing to do, like for readability. Yeah, but this is like, I was like, hey, why you need it, you know? Not actually needed, right? Because you have no binary. Okay, but what do you learn so far about the topic? What is the difference about unary and binary? So... yeah, but you should use it then if you don't want that it's going to be changed, right? You should use then const, right? You know, we have here unary. It makes no sense to use const here only for readability, right? Am I correct? Am I wrong? I mean, it's nice to have because if someone is reading it, he knows nothing will going to be changed. But if you know it's a unary, you know it already, you know? Actually. Because, you know, this here operator is a unary and this is a unary. Why you not have to explicit like say this is a const? You get my point, right? No, it's like why we have to have this. Can I modify it outside this? Like the this? Can I modify it in a way? If this is not const? I mean, if we have it like this here, right, without the const, can I modify this? No, right? I think you should always mark everything that can be const as const. The bool at 34. Yeah. The bool is not returned by reference, so it cannot be modified outside the function. But I would not get an error. So can I modify it like in the main function now? No, right? So doing, you mean in the main function if you're gonna say, but it's not defined. Of course, it would be an error if you say like something like point equal false. So, but if we have const, it will not change. Same shit. If you return an... Ah, you're right. Ah, yeah, you're right. Sorry, I'm wrong. If we would have it like this... yeah. And we have here then... Wait a second. Where? What I have to... the function prototype? You mean this here? Yeah, true. Still have here an arrow. Arrow non-const L value reference to the type bool cannot bind to a temporary of a type bool. We get it here already an arrow, right? Non-const L value reference to type bool. I have to check the topic R value and L value. It's kind of special in C++. Next time we're gonna relearn R and L values. But I'm getting the point, because now I have this, right? I'm returning the object, right? So I getting the address to the object, right? So I can modify the object. If it const, I can't. But I'm getting the point. Okay. I think this is enough C++ for today, man. Oh man, this is such a rough topic. This overloading thing in C++ is crazy. I think you need a lot of experience, and it's really easy to fuck it up. So the overloader operator for this class returns the Boolean value true if the point is set to the default value of the coordinate 0, 0. Thus, the above code produces the result point is set at the origin. Yeah, because it is. Oh, implement overload unary operator plus for the point class. Unary operator plus just returned its operand. It does not make negative values positive. The const determines the modifiable of the object. You call the method on. The reference-ness of the return value determines the modifiable of that. They probably are related, and so you almost always see reference in the return value and const on the function together. So my question is still then, so I'm returning this type here. So, okay. If I have the reference, I'm returning the object. What I'm returning here then? Am I creating a copy? What I'm returning then? If it's const. Are you getting my point? Return by value, a copy. Okay, makes sense, makes sense. Yeah, okay, got it. So I'm generating actually, and am I creating a new object? A temporary new object? Or is it just a copy of the value? Or from the value? Do you think you have grasped const member function? The return types is irrelevant. You can have void const member function. Yeah, maybe I should do const again, right? When you say object, I'm afraid you mean the point object. Yeah, true. Yeah, okay. Yeah, I got it. So we can say, okay, if it's not a const, right? And then we have this. So we have like kind of pointed, it's pointing to this object. And then we can modify in this object things, correct? And with const we can't. Right? So we're getting a copy. Oh, thanks a lot for this ride today, guys. It was a wild ride. Oh, man. We're not necessarily getting a copy. I thought actually the same. So it's like... But we have no reference type, you know what I mean? That's a little bit annoying me. So we're not getting a copy of the object, it's clear, but we're getting maybe a copy of the... It's still the same data. So we have still a pointer that... so we still have a pointer that points to the object, right? So we have actually we have then returning a pointer from type const. Can we say that? Like that this pointer is then const. Okay, but is it then just programming wise defined this way that we have it one time? I mean, it could be also bool with the reference and then const. You know what I mean? Is it just defined this way for readability? That if you're using const, that you will not have a reference then there? Or what is the reason? Next black hole. Are you getting my point? You mean this here? Okay. You said the minus operator. Yeah, of course, it's not gonna work. No, my question is now if I have not const, only this, right? If I have it like this, then I'm gonna do it like that, you know? You know what I mean? That make for me not that much sense. Oh, right, this is interesting. Can you maybe help me with the return type here still? You know, I'm not getting it if I have const, right? Then the return type will be like this. If I have not const, the return type will change to this. If I always returning the I'm getting a copy, right? If I have this here. Wait. You mean I can do also like this? Why this is then not working? Right. R value, L value. Okay. It has something to do with R value, L value. I get it. Yeah, we're gonna relearn tomorrow again, like R value, L values. I think that's a really important topic. It's also a little bit confusing, but I'm getting it, because if you have like the address, you can change it, right? So if you have the reference, so non-const L value reference to type bool cannot bind the temporary type bool. Non-const L value reference. Dummy is then an L value can bind to it. Dummy is then an L value and can bind to the reference of a return type. I need for this tomorrow a different example with R and L value, like maybe with this above, like that we're saying, okay, this is okay. So if you're doing this here, for example, it's the same thing again, right? I mean, this is, yeah. So please do this. Try defining a bool dummy. Line 36, line 37. Okay. As a return type. Bool return is correct. You mean if you do like, bool. We should define it before. What? Can you just send me what you want to show me? I'm just giving you the link. 1 second. I have it. So this you mean? Oh, I think I'm getting it. Okay. Okay, getting it. It's just it has just something to do with R and L value. I mean, yeah. Okay, got it. Sometimes it's not that good to overthink stuff, though. It's this stuff is hard. I programmed C++ for years before they introduced move semantics and stuff, and then they did. I could wrap my head around it for ages. So you're still programming in C++, by the way? What are you programming, by the way? So are you working for a company or company? Okay. So your main job is not programming or what? Template magic. Oh man. Okay. Okay, then I have to thank you a lot for helping me today. I think it's enough C++. Well, C++ is really special. It's kind sometimes juicy, but sometimes so cool if you're looking at, just checking out other languages, right? It seems like chilled in the C++ is just hard mode, right? It grabs you, yeah. You have to like it, right? The crap. It's gonna. So I think it is for today. Tomorrow, I'm not 100% sure if I'm able to stream. I'm gonna try hard to stream tomorrow again. My 2-3 hours. I think we did some good progress here, and yeah, see you probably tomorrow. I hope so. If not, we're gonna see us on Friday. Have some business to do tomorrow. So RCRNSTN, thanks a lot for your help. I'm out. I wish you a good evening. Reisbauer. Hau. See you.